It's really important that you can do these rates of change questions on your calculator. So I'm going to show you how to do this particular one on the Casio. So on the Casio, I'm going to use the table function. Okay, use table function. And the first is going to be the equation that models the height of the ball. So minus 4.9 x squared plus 19.6 x plus 1.4. Okay, now I'm going to go to the table now. Whoops, press that. So here I can set the table, and I've set it to start at 0 because one of the questions is what is the height at t is equal to 0, and I'm going up by 1 because I want to go up by 1. So now I press here table, and it gives me the values that I need. So the question, find the height at t is equal to 0, that's 1.4 meters, and t is equal to 2 seconds is 21 meters. The next question says find the average rate of change of the height of the ball from 0 to 2 seconds. So I need the difference in the rise over the difference in 1. So the difference in the rise is going to be 21 minus 1.4. So go back to run matrix now just to do a normal sum. So 21 subtract 1.4 and divide that by 2 because the difference in run is just between 0 seconds and 2 seconds. And so it's 9.8 meters per second. Right, now go back to the table because the next question is asking us to find the instantaneous rate of change at t is equal to 1, 2, and 3 seconds. So I need the gradient function. So in order to do that, I'm going to ask it to calculate the derivative of this equation. So now I press Option, and then I'm going to go to Calc, and I want this first one here, the first derivative. I want the derivative of y1, so I choose y here and 1. And then here, I want every value, so I'm just going to put in x here. And then I'm going to go to the table. Now, if I go to the table, this is the values that I need. T is equal to 1. The rate of change is 9.8 meters per second. T is equal to 2. It's 0, so that means it's not moving at all. And then t is equal to 3, it's negative 9.8 meters per second. And the question says explain that. Well, if you imagine a ball being thrown up and then down, well, obviously at t is equal to 1, it's traveling at 9.8 meters per second. And at t is equal to 2 seconds, it must be at the top of its trajectory. So it's sort of, for that instant, it's not moving before it then goes down. At 3 seconds, it's traveling downwards at negative 9.8 meters per second. So make sure you know how to use this calculator properly so that you can be efficient in these calculations.